Welcome to my YouTube channel. In this video, we are going to be looking at equation of rolling objects down inclined plane. So in this video, we look at an object, actually spherical or any form of round shape moving down an inclined plane. So we'll start with this. So this is a sphere. It can also be a cylinder that is rolling down this inclined plane that is subjected to an angle theta. So first thing we need to do is to check the forces acting on this body as it rolls down the plane. It's in this particular case, we are looking at rolling. No slipping is involved, just rolling. So forces that are acting on these objects include the mg sin theta, the frictional force given as F, then the weight, which is given as mg. Then we have the reaction, the force opposing the reaction, mg cos theta. The reaction is pointing in this direction. So now that we have written the forces acting on this particular object, we can check all the forces and sum them along this axis, and also sum the ones along this axis. So we'll consider the first case. Now, since the object is moving down, so we expect that this mg sin theta minus the frictional force must be equal to ma. If we rearrange this one, it gives mg sin theta minus mu r equal to ma. F, frictional force, is given by mu r. Right? So if we also consider the torque that is causing this stuff to roll, the sum of torque on an object, right, must be equal to what? The moment of inertia times the angular acceleration. And the only force that is causing this object to roll is the frictional force, because as it pulls, then this particular object rotates and rolls down. So from this point, we have that our F equal to I alpha all over R. And for a solid sphere, the moment of inertia is 2 over 5 capital letter M R squared, where this is the mass of the object. If we make this substitution back into this expression, we'll have this expression. So at this point, R can take care of R, and it will lead to this. And it has also been established in one of our previous videos that R alpha is just the tangential acceleration. And that gives us this. And that tangential acceleration of this object is also the acceleration as it moves down. Now that we have established that F equal to 2ma all over 5, we can substitute it here and see what comes out of it. So we have mg sin theta minus 2 over 5 ma equal to ma. We can send this one to this part, and that gives us this, which, if you simplify, gives 7 over 5 ma. Okay, so if we connect this and this, we can make a disorder formula from this point, and that gives us this. We've already taken care of our m. Making a disorder formula, we have this, a equal to 5 over 7 g sin theta. Now, recall that the original expression that we brought out is this. We might also be interested in determining our mu, which is the coefficient of friction between the object and the block. Now that we have established that A equal to 5 over 7 g sin theta, we can substitute here and see what comes out of it. Remember that our R equal to mg cos theta equal to ma. And substituting A equal to this part here and taking care of our m's, we have this expression, right? Okay, so we now move to the next stage, which is g sin theta minus this one come here, then this one going to this part. We have this expression. At this point, we can simplify this one, and that gives us our g also takes care of it, And if you simplify, we get 2 over 7, because 1 minus 5 over 7 will give us 2 over 7 sin theta, this. If you make your mu de Saussure formula, we have this. So we can also determine the coefficients of friction between the object and the plane, and it's given by 2 over 7 tan theta. That's it. You might also use the same approach for any object that has a round shape. So let's look at some. You can use it for this as it rolls down. What we just need to do is, wherever we see I in our previous slide, we'll replace with this expression. We can also use this one. We can use this. We can use this. We can use this. The moment of inertia of any one of them. So once we get the moment of inertia of any one of them, we can derive the equation for such shape and object. I hope this helps. Please like, share, and subscribe to my YouTube channel. Thank you.